Hey everyone, I'm Jason. I'm part of Group 4, and we'll be presenting our project, which involves analyzing Uber data while utilizing Amazon Web Services and Hadoop MapReduce to perform statistical analysis on said Uber data. Me and my group mates will be discussing each of the components in our agenda, and we hope that by the end of our presentation, we can demonstrate the relevance and quality of our analysis. All right. Anyone who has been to New York City, more specifically Manhattan, could probably tell you that it's unlike any other city in the world. One of its defining features, unfortunately, is how crowded it seems to be, especially during even hours. Manhattan has an expansive subway and bus system that is set up to try and alleviate this issue. Uber's meteoric rise in popularity over the last few years has further exacerbated the traffic congestion on the roads, especially in Manhattan. The question becomes, what can Uber do to help alleviate the traffic congestion, especially in NYC's busiest borough of Manhattan? Our plan is to provide data that will demonstrate Uber's contribution towards the traffic congestion issues in Manhattan in comparison to its impact to the traffic conditions in other New York City boroughs. The solution will be to encourage Uber to have a higher percentage of its pickups occur outside of Manhattan, where the metro and bus systems are not as expansive. We also hope that this will serve as an example for other for-hire vehicle companies on how they should tailor their services and distribute it amongst the 5 boroughs of New York City. So the data set that we selected to use for our project was provided by Uber to the site 538, who eventually posted all the data they received on GitHub. This data set contains attributes such as pickup times, pickup locations, and the company responsible for these pickups. The entire data set contains entries from Uber and other for-hire vehicle companies for a total of almost 18 million data points. We chose to focus on those provided by Uber from January through June in 2015, since it is the most popular for-hire vehicle company out right now and also represents the most recent data set provided. Okay, so we ended up selecting Hadoop MapReduce to perform our statistical calculations on our selected dataset. The statistics we chose for our analysis are not very complex, but the dataset we will be performing them on is rather large. Hadoop allows us to perform our desired task with better performance and speed than either Pig or Hive would allow us on this dataset that we are using. Another factor was that our group was already familiar with Hadoop MapReduce jobs due to the homework assignment we had early during the semester. Also, Hadoop being open source and free didn't hurt in our selection of it as our framework to execute our job.
Thanks, Jason. Hi, everyone. My name is Subramanian, and I'm going to explain about the design of Amazon Web Services and the advantages of using AWS. AWS is a cloud-based platform which offers a broad set of global cloud-based products, including compute, storage, databases, analytics, networking, mobile developer tools, management tools, IoT security, and enterprise applications. User has a better control over the application. The user can also create and run multiple data nodes for MapReduce jobs, which can be implemented over complex datasets containing more than 1 million records. And of course, this should be familiar to all of us since we have already used it for doing our programming assignment earlier this semester. But the main advantages of AWS is it is highly reliable, scalable, and it has a low-cost infrastructure platform in the cloud that powers hundreds of thousands of businesses. Moving on to the implementation, we actually took the dataset from Kaggle, which consists of almost 2 million data points, and the name of that file is highlighted in the PPT. The attributes of the dataset include the date, time of pickup, and the location ID that is associated with the pickup. Since there were two dataset tables for maintaining the time and zone of the pickup, we designed a Python script which merges the two files into one. which makes the data processing even faster and easier. The output of the script is the merge file, which provides zone and borough information for each location ID. In order to analyze the dataset and determine the statistics, we made use of the Hadoop MapReduce, which is a software framework for easily writing applications which process vast amounts of data in parallel on large clusters of commodity hardware in a reliable, fault-tolerant manner. As we cannot see from the MapReduce architecture diagram, a MapReduce job usually splits the input dataset into independent chunks, which are processed by the map tasks in a completely parallel manner. The framework sorts the output of the maps, which are then input to the reduced tasks. Typically, both the input and output of the job are stored in a file system. It takes care of scheduling tasks, monitoring them, and re-executes the failed tasks. In our case, we had 5 MapReduce tasks written in Java, which was then integrated into a single large MapReduce job to output each of the desired statistics. The statistics include percentage of pickups inside Manhattan, percentage of pickups outside of Manhattan, most popular pickup hours, most popular pickup areas, and hours for each area that are higher than average pickups. The design programs were then run and tested on the AWS EC2 instances. We created the large instances in order to handle our dataset, which consisted nearly of 2 million data records. The architecture diagram of AWS specifies how the instances are connected with the master nodes. We actually created a common security group and used it to build the other instances, which were then accessed using the same private key. In the earlier assignment, we used the AMI based on Ubuntu with Hadoop installed, but for this assignment, we created a single name node or the master node and created 3 data nodes or the slave nodes on Amazon EC2 to perform the MapReduce jobs on our dataset. I'll now hand over the presentation to Huzefa, who will explain the results of our analysis and the performance evaluation of the instances.
After talking about implementation of our project, let's talk about some results. As you can see in this pie chart, which represents the pickup inside Manhattan and outside Manhattan. As you can see, Manhattan takes 72% of total Uber pickups in New York City, while outside of Manhattan takes 28%. Okay, so let's look into a few more insights which were given by our data. On the left hand side, we can see the most popular hour for Uber pickups in New York City, which shows 3 pickup hours at which there were maximum number of pickups in the whole data. And on the right side, we can see the most popular locations in New York City. These locations are in a sorted order. It's according to the ranking. This shows that most pickup happens at Midtown Center, and in this list, the least pickups out of this 10, the least one happens at JFK Airport. This result shows the higher than average pickup hour per location. That means if you want to avoid any kind of surcharge, you can avoid it by avoiding the following hours for any given location. Okay, so let's see some evaluation regarding performance. As you can see in the graph, initially we had 1 master node and 3 data nodes. Using that, it took 267,965 milliseconds to complete the whole MapReduce task. When we decreased 1 data node, that is 1 master and 2 data node, it took 456,483 milliseconds. So it's around 58% of performance decrease with just 1 data node decreased. Okay, so let's talk about fault tolerance. As you can see in the graph, initially we had 1 master and 3 data node, and it took 267,965 milliseconds. After that, what we did is we terminated one node in middle of processing of MapReduce. It was actually doing map task. When we did that, it took 340 to 3 milliseconds to complete the task. So from the insight which we got from the Uber pickup data, we can conclude that there is an overwhelming majority of Uber pickups inside Manhattan, that is 72%, and most pickup occurs during 6 to 8 p.m. that's peak hours. So for this, we suggest that that Uber should shift pickups to serve a larger percentage of passengers outside of Manhattan, which would encourage Manhattan inhabitants to use public transportation, which in turn will reduce congestion, and there will be less fuel emission. By doing so, Uber would set an example for other FHVs. So thank you for listening to our project presentation. Hope you enjoyed it and have a great day.